Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm your host, Anna, and today we've got an exciting lineup of stories covering everything from supersonic spacecraft to mysterious objects in space. We'll be exploring groundbreaking achievements in aerospace, fascinating discoveries from the far reaches of our solar system, and intriguing new research that's changing our understanding of the cosmos. Let's get started. In an exciting development from the aerospace industry, Dawn Aerospace has achieved a remarkable milestone with their Mk-11 Aurora spacecraft. During a test flight near Mount Cook in New Zealand's South Island on November 12th, the craft successfully broke the sound barrier, reaching Mach 1.1 while climbing to an impressive altitude of 82,500 feet. That's about 25 kilometers up. This achievement marks the first time a civil aircraft has reached supersonic speeds since the retirement of the iconic Concorde, making it a significant moment in aviation history. What makes the Aurora particularly special is its innovative design and capabilities. The spacecraft is engineered to perform something that's never been done before, reaching the edge of space twice in a single day. According to Stephen Powell, Dawn Aerospace's chief executive, the Aurora is designed to hit speeds of Mach 3.5 during both ascent and re-entry. The company, which maintains headquarters in both the Netherlands and New Zealand, has been methodically testing this latest model over recent months, and these results demonstrate the immense potential of their rocket-powered aircraft technology. The Aurora also set another impressive record during its test flight, becoming the fastest aircraft ever to climb from ground level to 20 kilometers. This breakthrough represents a significant step forward in the development of reusable space technology, potentially opening new possibilities for more frequent and efficient access to space. Next up, NASA's James Webb Space Telescope has made another groundbreaking discovery, this time in the Orion Nebula, where it has confirmed something that has intrigued astronomers for decades. Scientists have found that some of the protoplanetary disks they've been observing actually surround brown dwarfs, fascinating objects that exist in a cosmic gray area between stars and planets. These brown dwarfs, sometimes called failed stars, lack the mass needed to sustain hydrogen fusion in their cores. Despite being too small to be proper stars, they're still significantly larger than planets. The Webb telescope's observations have revealed that these objects are surrounded by disks of gas and dust, similar to the protoplanetary disks we see around young stars. The study focused on several objects in the Orion Nebula, which lies about 1,300 light-years from Earth. Using Webb's advanced infrared capabilities, researchers confirmed 20 objects as brown dwarfs, with some having masses as small as 5 times that of Jupiter. What's particularly exciting is that 2 of these brown dwarfs were found to have protoplanetary disks that were previously spotted by the Hubble Space Telescope. This discovery is reshaping our understanding of how these cosmic objects form and evolve. The presence of these disks suggests that brown dwarfs might form in a similar way to stars and could potentially host their own planetary systems. The findings are especially significant because they represent some of the coolest and least massive protoplanetary disks ever detected. These observations have only scratched the surface of what we might learn about brown dwarfs in the Orion Nebula. With hundreds more potential brown dwarfs waiting to be studied, Webb's continued observations could help us better understand these mysterious objects and their relationship to both stars and planets. China made waves at their International Aviation and Aerospace Exhibition last week with the announcement of their new Haolong spacecraft. That's Chinese for dragon. This reusable cargo shuttle has officially entered the engineering phase and represents a significant step forward in China's space capabilities. The Haolong is notably compact compared to NASA's retired space shuttle, measuring just 10 meters in length with an 8-meter wingspan. But don't let its smaller size fool you. This autonomous spacecraft is packed with cutting-edge aviation technologies and has been specifically designed to provide vital logistical support for China's Tiangong space station. According to chief designer Fang Yuanping, the Haolong will launch into orbit aboard a commercial rocket. Once in space, it will deploy solar panels and dock with Tiangong, allowing taikonauts to access its cargo bay. After completing its mission, it will make an atmospheric re-entry and land horizontally on a runway, much like an aircraft. The spacecraft can then undergo maintenance and prepare for its next mission. The Haolong is one of two winning designs selected by the China Manned Space Agency in their search for low-cost commercial cargo spacecraft. This development comes as China's commercial space industry continues to expand rapidly, with market projections suggesting it could reach a value of over $320 billion by the end of this year. This new cargo shuttle marks another milestone in China's growing space program, demonstrating their commitment to developing sustainable and reusable space technologies that could play a crucial role in their future space exploration plans. Let's get a Mars update. NASA's Curiosity rover is preparing for an exciting new chapter in its Mars exploration, but not before capturing one final look at an area that's left scientists scratching their heads. The rover recently completed a stunning 360-degree panorama of the Gades Vallis Channel, an area it's been studying for the past year that's proven to be full of surprises. Perhaps the most intriguing discovery in this region has been a field of pure sulfur stones, something never before seen on Mars. When Curiosity rolled over one of these mysterious rocks, it revealed bright yellow crystals inside. What makes this finding particularly puzzling is that on Earth, sulfur deposits are typically associated with volcanic activity or hot springs, yet scientists haven't found evidence of either in this area of Mount Sharp. The rover is now setting its sights on an intriguing new target, a formation known as the Boxwork. When viewed from orbit, these features look like spiderwebs stretching across the Martian surface. Scientists believe they formed during Mars's final wet period, when mineral-rich water seeped into rock fractures and hardened. As the surrounding rock eroded away, these mineral-filled cracks remained, creating the distinctive web-like patterns we see today. This formation is particularly exciting because it spans an impressive area of 6 to 12 miles and could provide valuable insights into Mars's transition from a wet world to the dry planet we see today. Even more intriguingly, the environment that created these features bears similarities to places where early Earth microbes could have thrived, making it a compelling target for understanding Mars's potential for past life. As Curiosity embarks on this months-long journey to the Boxwork formation, it leaves behind the Gades Vallis Channel with more questions than answers about its sulfur stones and how this channel formed so late in Mars climate history. But that's the nature of scientific exploration. Each discovery opens the door to new mysteries waiting to be solved. Speaking of Mars, and looking to our future there, a fascinating breakthrough in Mars landing technology has emerged through an unexpected collaboration between NASA and SpaceX, potentially solving what was once thought to be an impossible challenge. Back in 2007, even NASA's top landing engineers were skeptical about our ability to land human-scale missions on Mars. The problem? Mars's atmosphere is too thin to land like we do on Earth, but too thick to use lunar-style landing methods. The key challenge has been what engineers call the supersonic transition problem. Any spacecraft heading to Mars arrives at incredibly high speeds and needs to slow down dramatically in just a few minutes. For context, the Perseverance rover was traveling at a blistering 12,100 miles per hour when it hit the Martian atmosphere. But a solution has emerged from an unlikely source: SpaceX's efforts to land their Falcon 9 rocket boosters back on Earth. When SpaceX began testing supersonic retropropulsion, firing rockets backward while moving at supersonic speeds, NASA saw an opportunity. The space agency partnered with SpaceX to study this technique, and what they discovered was remarkable. Rather than causing instability as feared, firing engines backwards during supersonic flight actually creates a protective bubble around the spacecraft, shielding it from buffeting and excess heating. This discovery has completely changed the outlook for landing large payloads on Mars. While significant challenges remain, such as protecting engines from debris and dealing with Mars's unpredictable weather, this breakthrough has transformed what once seemed impossible into an engineering challenge that can be solved. As one NASA engineer put it, they're essentially doing what Buck Rogers showed us in the 1930s, firing engines backwards while going really fast. And time for one more intriguing discovery today. In a fascinating new study, astronomers have discovered that up to a third of stars may have devoured some of their own planets. This celestial cannibalism helps explain a long-standing mystery about why some stars born from the same cosmic nursery show unexpectedly different chemical compositions. When stars form from the same giant molecular cloud, they should have nearly identical metal content. However, detailed observations have revealed that some sibling stars show pronounced differences in their metallicity, the abundance of elements heavier than hydrogen and helium. The research suggests that these differences arise when stars consume rocky planets that orbit too close to them. These planets, rich in metals and other heavy elements, effectively pollute their parent stars, leaving behind a distinctive chemical signature that astronomers can now detect. The study focused particularly on ultra-short period planets, worlds that orbit extremely close to their stars, completing a circuit in just a few hours. While these planets are rare today, found around only about 0.5% of Sun-like stars, the evidence suggests they may form much more frequently, but often meet a fiery end. The process can happen in several ways, but the most common appears to be through what scientists call low eccentricity migration, where planets in multi-planet systems gradually spiral inward toward their star. This cosmic dance typically occurs between 100 million and 1 billion years after the planetary system forms. This discovery not only helps explain the mysterious metal content differences between sibling stars, but also provides new insights into the dangerous lives of planets that orbit too close to their stars. It seems that in many planetary systems, what we observe today may be just the survivors of a much more crowded early history. That's all for today's episode of Astronomy Daily. I'm Anna, and thank you for joining me on this journey through the latest developments in space science and exploration. From supersonic spacecraft to planet-devouring stars, it's been another fascinating day in astronomy. Don't forget to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and catch up on all the latest space and astronomy news with our constantly updating newsfeed. While you're there, you can also listen to all our back episodes. Want to stay connected? You can find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until tomorrow, keep looking up and wondering about the mysteries of our cosmic neighborhood. I'm Anna, and this has been Astronomy Daily.